Thank you, sir. Introducing the Sri D.V. Suryanarayan Raju Garu, the General Manager, E&M, Electrical and Mechanical. Uh, Sir is presently working as a General Manager, E&M, at a Singer and Thermal Power Plant in Singer and College. He joined as a Junior Executive Trainee, E&M, in 1986 in Singer and College and have a vast experience of over 37 years in the SCCL. Prior to his transfer to the STTP, he worked as a general manager E&M Solar Energy Department, Singer and College Company Limited. During his tenure as a GM E&M Solar Energy, he has led the team in a commissioning in the 179 megawatt solar plants in the Singer and College Limited, and also the instrumental in planning and tendering another 81 megawatt solar plants in the Singer and College, which includes the 15 megawatts floating solar plants in the reservoirs of the STTP. He is involved in the design, execution, and commencing of 5 megawatts floating solar power plant from concept to commissioning. Earlier, he served in various capacities in the Singer and College Limited, particularly in open cast projects where standards in maintenance of HEMS, heavy earth moving machineries, were treated in a benchmark. He also served in Andhra Pradesh Heavy Machinery and Engineering Limited, that is formerly known as the APHMEL, Vijayawada, which is a subsidiary of the Singer and College Limited, whereas he played his key role in establishing the performance of the APHEMEL. Presently, as a general manager, he is actively looking after the erections and commissioning activities of the flue gas desulfurization unit for the 2 into 600 megawatts STPP as per guidelines of the MOEFCC. Further, he is pursuing the activities pertaining to installation of the proposed 1 into 800 megawatt supercritical thermal power plant at HTTPP, which is currently under the contract awarding stage. This is a brief about the honorable of today panelist one. And I also privileged to introducing the Sri S. Srinivas Rao Garu, a second panelist to today our technical webinar, Deputy General Manager of E&M. Sir is presently working as a Deputy General Manager E&M, Regional Coordinator, Solar Energy Department of the Singer and College Limited. He joined as a Junior Executive Trainee E&M in 1989 in the Singer and College Limited, and having vast experience of the 34 years in the Singer and College in mining and power sector. During his tenure as a DGM E&M Solar Energy Regional Coordinator, he has expertise in the commissioning of the 118 megawatt solar PV power plants in different locations of the SCCL. From concept to commissioning, which also includes 5 megawatts floating solar PV power plant, first of its kind in India, over reservoirs of this STPP SCCL. Earlier, he served in various capacities in Singer and College, particularly in power systems of the open cast projects, where he was referred as a power systems specialist. He has played as a key role in the early closure of the erections and commissioning of the activities pertaining to electrical systems of the 2 into 600 megawatts SCTPP. Presently, he is looking after implementation of the BESS, converting gray hydrogen plant into the green hydrogen plant, supervising erections and commissioning of the 33 megawatt solar PV power plants under his region, as well as preparation of the DPRs and obtaining the feasibility reports from the state government for proposal of the 232 megawatts solar PV power plants in SCCL. These are our second panelist of the today our webinar. I also privileged to be introducing our today moderator of this webinar, Sri Honorable Chairman of the Kottagudam Lok Center, Sri G. S. Janaki Ramaya sir, the Chairman Kottagudam Local Center, and also today moderator of this technical webinar. Sir is after completion of the AMI in the section B of the 1985 after the fellow of the mechanical engineering division. A certified course in the COBOL is also expressed and computer language from the SV University, Tirupati. His career is joined in Singer and College as a junior executive trainee at Ilandu, worked in open cast projects, auto workshops, and stores in various capacities. Worked as an area engineer, head of the E&M discipline at Ilandu, and also as a GM E&M, staff office to the director E&M, Presently working as a general manager E&M in solar energy from the August 2020 onwards. I hand over these sessions to the today moderator, Sri Janik Ramesh sir. Please start our panelist programs.
Thank you, Kanu Kumar Garu.
Thank you.
Today, in this webinar, we are going to discuss the glass-to-glass PV module floating solar power plants. What the design, challenges, and its performance. Very, very interesting subject. And really, we have faced so many challenges in executing the project. So, Mr. Suryanarayan Garu is very instrumental in addressing all the problems timely, and he has already commissioned 5 megawatt floating solar project at STBP Jaipur. Now I will request Sri Raj Garu to continue the webinar. Is it visible?
It is not visible.
Screen.
Screen is just empty without a PPT.
No?
No, sir. No. Just name is like that.
Is paused.
Just you click share share screen. Okay.
ఇప్పుడు వచ్చిందా?
రాలే సార్, ఇంకా రాలే. ఒక నేమ్ వస్తుంది సార్, నేమ్ వస్తుంది అంతే.
అదే పెట్టాను.
క్లోజ్ చేసి స్టాప్ షేరింగ్ చేసి How is it visible?
No, sir. No.
More like it. More and more archipelago.
సార్ మీరు పీపీటీ బ్యాక్గ్రౌండ్ ఓపెన్ చేయండి. పీపీటీ బ్యాక్గ్రౌండ్ ఓపెన్ చేసి అప్పుడు షేర్ స్క్రీన్ చేయండి. పీపీటీ బ్యాక్గ్రౌండ్ ఓపెన్ చేయండి ఫస్ట్.
ముందు స్టాప్
ఊర్లో చూస్తాను.
బెస్ట్ గా చేయండి.
పీపీటీ బ్యాక్గ్రౌండ్ ఓపెన్ చేసి అప్పుడు షేర్ స్క్రీన్ చేయండి.
సార్ రాదు సార్ ఒకసారి మళ్ళీ సార్ షేర్ అన్నాను సార్. ఇంతకుముందు మళ్ళీ ఓపెన్ చేయండి సార్. షేర్ ఇప్పుడు తీసుకున్నారు సార్, కింద అక్కడ తీసుకోండి సార్. షేర్
అదే కదా తీసుకున్నాను.
సెలెక్ట్ చేయండి సార్. ఇప్పుడు సెలెక్ట్ చేయండి సార్. మళ్ళీ అది సెలెక్ట్ చేసిన తర్వాత కింద షేర్ అని ఉంటుంది సార్, చూడండి సార్. ఆ సెలెక్ట్ చేసి కింద
గ్రీన్ కలర్.
Is it visible now?
No, sir. No. సేమ్ ఒక నేమ్ వస్తుంది సార్, నేమ్ వస్తుంది అంతే.
మోర్లోకి వెళ్ళండి సార్ ఒకసారి. మోర్లోకి
ఇప్పుడు పీపీటీ ఓపెన్ చేయండి ఫస్ట్. పీపీటీ ఓపెన్ చేసినాక అప్పుడు షేర్ సిక్స్ చేయండి, చూద్దాం ఇది.
ఫస్ట్ పీపీటీ ఓపెన్ చేసేమంటావా?
ఫస్ట్ పీపీటీ ఓపెన్ చేయాలి సార్. ఓపెన్ చేసినా అప్పుడు మీరు షేర్ స్క్రీన్ చేయాలి. డెస్క్టాప్ ఓపెన్ చేయండి పీపీటీ.
డెస్క్టాప్ అక్కడే ఓపెన్ చేయండి సార్. ఫస్ట్ డెస్క్టాప్ మీద వెళ్ళండి సార్. విండోస్ కీ బట్టి డి కొట్టండి సార్. విండోస్ కీ బట్టి డి నొక్కండి సార్. విండోస్ కీ బట్టి డి నొక్కండి సార్. సార్ ఇప్పుడు ఇది ఓపెన్ ఇక్కడ ఓపెన్ చేయండి సార్. రన్ చేయండి సార్.
అప్పుడు షేర్
షేర్ ఇదే సార్. అచ్చకూడదా సార్ ఇప్పుడు మనం చేసిన షేర్ సార్.
ఇప్పుడు సార్ ఇప్పుడు నవ్ ఇట్స్ ఓకే సార్, నవ్ ఇట్స్ ఓకే.
Okay,
it
thank
is
you,
okay,
thank
sir.
you.
Please carry on, sir. Please carry on.
Yeah. Sorry for the interruption. Now the problem starts.
First of all, good evening, Mr. Jankiram, Srinivas, Karun Kumar, and Mr. Sen, and all the participants. So, it is an opportunity for us to share our experience on this floating solar power plants. So, these actual 2 sessions, my colleague Mr. Srinivas will give the complete presentation on these glass to glass technologies and whatever the challenges we have faced and the success story of this 5 megawatt floating solar power plant at STPP Singareni Thermal Power Plant in Singareni. So he will tell about all those glass to glass technologies. Before that, I will briefly tell about what is the scenario of power sector and solar energy, how it is growing up in our country, and briefly about the floating solar PV plants, what are the technologies and what are the basic parameters and what is the selection criteria, and all the basics about this floating solar power plant. It is the first session. I will concentrate on that. Subsequently, how we have faced the problems and how we have commissioned and about the glass to glass technology. Subsequently, our Srinivas will continue. So this is the briefly about our presentations. So first of all, we both are, including Jankaram, we three, and Srinivas, myself. We all three are working in Singareni Colleges Company Limited. This Singareni Colleges Company Limited is a public sector unit primarily located in the state of Telangana. So this is our primary business is coal production. Almost every year we are producing 70 million tons of coal, meeting the needs of energy needs of all the 4 states of southern states of India. So as a part of diversification, we undertook into this power sector by installing 1200 megawatt thermal power plant, our own megawatt thermal power plant in 2016. It was commissioned in 2016 and it is working very well. It is all in the entire country. It is always in the first in the PLF ranking. It is almost first to 6 positions in the 2022-23. For the first 10 months, it is in the number 1 for the state, central, and private sector thermal power plants among India. All the 200 almost 200 major thermal power plants or the STPP Singareni thermal power plant stood first PLF in the PLF performance of plant load factor, with the highest plant load factor. So afterwards, with our visionary and dynamic leadership of our respected CNMD Sridhar IAS, so we entered into this solar power plants also. The first coal company in India, government sector, which entered in even thermal power plants and solar plants also. It is the first coal company, public sector unit. So we are already commissioned 224 megawatt thermal solar power plants in our own lands in the state of Telangana. So all the whatever the power generated from these solar plants are for our captive use. That is for the use of our own consumption. So our target is to complete now the 220. After this, around 76 megawatt solar plants are under the erection. So further around 220 megawatt solar plants, it is under tendering stage. My colleague Mr. Jankiram is leading that department. So our target is by 2024 to become the net zero company. So it will be the first public sector unit by 2024, which is by achieving this net zero targets. So that is our background and our targets on solar plants. We have not only ground mounted, we have successfully commissioned this floating solar plant, 5 megawatt floating solar plant on our Single Thermal STPP raw water reservoir on the water surface area. And again, one more credible achievement is we are also commissioning one of the solar power plant on the overbed and dumps of open cast projects. It is also unique nature, first time in the India on overbed and dumps of such that the wastelands, whatever the dumps can be utilized. So there also we have already taken up and our work is already started. So that is also a challenging job because the piling and all those things is a challenge and requires many design advancements and technologies. So regarding this floating solar, as already I have told, 5 megawatt is commissioned and it is successfully working. And another 10 megawatt in the same reservoir, we are going to commission. Already works are started and we are expecting next 4 or 5 months this floating solar on the 10 megawatt solar plant will be added to our fleet. So this is about the floating solar, our solar plants in Singareni. So when we I briefly tell about the scenario of our power sector in India at a glance. So when we see all the total installed capacity of so total installed capacity of our power plants, that is thermal, solar, whatever it may be, it is 4,22,000 megawatt as on this is as per the CEA, Central Electricity Authority information from CEA. So out of 4,22,000 megawatt, around 2,06,000 is from coal, that is thermal power plants is the 2,06,000 megawatt power plants we are having in the total country. So other than this lignite, gas and diesel, they put together around 30,000. So total from fossil fuel, it is 2,37,000 megawatt capacity out of 4,22,000. 2,38,000 is from fossil fuels. So when we go for this renewable energy side, so this hydro power plants is 46,850 megawatt power plants, already hydel plants are working, and wind is 43,773, and solar as on date it is 70 gigawatt, that is 70,097 megawatt already commissioned in India. So this is the total about total installed capacity. So we know that there is a lot of thrust to go to increase our renewable energy capacity year by year. Our target as per the COP26 Paris Agreement by our Honorable Prime Minister Sri Narendra Modi ji, our commitment is to go for 500 to achieve 500 gigawatt renewable energy by 2030 and net zero by 2070. These are the targets we put our country has put up. So this is now we are at around renewable energy. It is around out of 500 gigawatts target, we have achieved around 183 gigawatt. So a lot of plants have to come in the near future. So we very know one that thousands of megawatts of plants are now under the election stays mainly in the states of Rajasthan, Gujarat, and all those things. So these are the brief details about the power sector in the India. So now let us go for this about discussion about this floating solar power plant. So as already I have told, our India, we are having the almost 250 to 300 days a year clean sunny weather is experienced in India. So we are having a lot of potential for the developing these solar plants in our country. So per year, there is every chance, every possibility of energy potential to produce 6,000 million gigawatt hours of energy per year. This is the our potential, available potential in our country. So if the wasteland, if even whatever the wasteland, like we are commissioning a lot of plants at Rajasthan desert area and Gujarat, that Kutch area and all those things. So if you can utilize even 3% of the wasteland area also, you can able to put the commission 748 gigawatt of solar power plants in the country. So as I already told, our aim is to achieve 500 gigawatt renewable energy by 2030. So when compared with when we go for this floating solar plant, in the when we see in the first the commission in Japan, very small plant, 25 kilowatt plant in 2007, whereas in our country, the first floating solar plant, that is also very small capacity, 10 kilowatt floating solar power plant in a small pond in nearby Calcutta. So this along with TEDI and World Bank Group, they have conducted a survey about the ponds and reservoirs available in the country.
సార్ స్లైడ్స్ మూవ్ కావట్లేదు సార్, స్లైడ్స్ మూవ్ కావట్లేదు. స్లైడ్స్ క్లిక్ చేసుకుంటారు.
ఎక్కడ ఉంది అది? అవును, స్క్రీన్ మీద.
Srinivas.
చెప్పండి సార్.
వినపడుతుందండి?
సో పని చేయండి, మీ దగ్గర నుంచి షేర్ చేయండి, ఎక్కడి నుంచి ప్రజెంట్
రైట్. ఒక నిమిషం సార్, ఒక నిమిషం
షేర్ మీరు చేసేయండి. ప్రెజెంటేషన్ మీ దగ్గర ఉంది కదా?
రైట్, ఒక నిమిషం చేస్తాం.
సో ఐ విల్ ఎక్స్ప్లెయిన్.
రైట్, వన్ మినిట్. అంటే మీరు క్లోజ్ చేయాలి సార్, మీ స్క్రీన్ క్లోజ్ చేయాలి మీరు.
నేను చేస్తున్నాం.
మీరు క్లోజ్ చేస్తేనే మాకు పాజిబుల్ ఉంటుంది. రైట్,
క్లోజ్ చేసాం చూడండి.
You cannot so permission కావాలి సార్. You cannot start to screen share while the other participant is sharing. So Mr. Kingshuk has to give permission to
స్టాప్ షేరింగ్ చేసాం కదా, కాదంటే ప్యానలిస్ట్ మనం అమ్మన్నాం కదా, రాదేమో.
Sir, please share your screen, sir. Any problem, sir?
Yeah, Mr. Srinivas will share the screen. You give permission.
Sir, permission is given, sir. So Yes, sir, it is coming again, sir. No problem.
Okay. సార్ సార్ మీకు విజిబుల్ సార్ విజిబుల్ వస్తుందా విజిబుల్ మీకు
రావట్లేదు స్క్రీన్
మీ నేమ్ ఒకటి వస్తుంది
మేము ఇక్కడ చేస్తే యువర్ స్క్రీన్ షేరింగ్ ఈజ్ 1 minute పాస్వర్డ్
అంటే మీరు కూడా ఇందాకట్లో మళ్ళీ ఓపెన్ చేయండి ఇందాక మాకు కూడా వచ్చాం
అవును అదే
So I think some net issues are there, so that's why it's been not shared.
సో ఇప్పుడు వస్తుంది సార్
రావట్లేదు
స్క్రీన్ షేరింగ్ పాస్వర్డ్ వస్తుంది పైన వెళ్ళదు స్క్రీన్ షేరింగ్ పాస్వర్డ్
Please share your screen, sir. It is coming on the midway. Please share.
The screen sharing is faster.
శ్రీనివాస్ ఇందాకలాగా మీరు స్క్రీన్ మీద ఓపెన్ చేసి అప్పుడు మళ్ళీ చేయండి
మీరు వస్తుంది సార్ యూఆర్ కమింగ్ కాకపోతే మీది ఏమైతుందంటే పాస్వర్డ్ వస్తుంది స్క్రీన్ షేరింగ్ షేర్డ్ మొత్తం అదే ఉంటుంది సార్
మీరు రావట్లేదా మీ దగ్గర నుంచి
చూస్తాను సార్ ఒక్క నిమిషం
Otherwise, you can put your PowerPoint in mcdb@iindia.org. I can share from here.
ఇప్పుడు వస్తుంది సార్ విజిబులా సార్ నవ్వుడు విజిబులా సార్ ఓకే మేము సెకండ్ స్లైడ్కి వెళ్తాం సార్ రైట్
స్లైడ్ మారట్లేదు శ్రీనివాస్
మారుతుంది
మీకు మారుతుంది ఇక్కడ మారట్లేదు సేమ్ ప్రాబ్లం అవుతాయి
ఓహో అంటే ఎవ్రీబడి సేమ్ ప్రాబ్లం ప్లీజ్ టెల్ మీ
ఉండొచ్చు
కరుణ్ కుమార్ గారు
అరుణ్ కుమార్ గారు
Please continue, sir. Please continue.
Mr. Kishore.
We are moving slides, sir.
ఇక్కడ అవ్వట్లేదు స్లైడ్ చేంజ్ అవ్వట్లేదు శ్రీనివాస్
స్లైడ్ చేంజ్ కావట్లేదు సో మీదన్నా కాకపోవచ్చు వేరే వాళ్ళని అడుగుదామా
అడగండి ఎక్కడైనా అదే ప్రాబ్లం ఉన్నట్టుంది
కర్ణాకర్ గారు
కరుణ్ కుమార్ గారు Mr. Kishore.
Sir, please continue, sir.
Kindly, anybody tell regarding screen is moving, slides are moving.
Sir, please continue, sir.
It's not moving.
మీరు క్లోజ్ చేయండి శ్రీనివాస్
క్లోజ్ it.
స్క్రీన్ షేరింగ్ క్లోజ్ చేయండి మాది వస్తుంది అప్పుడు
Now it's okay, sir. Now it's okay. Now moving, sir. Now moving.
Moving,
Now moving, sir. Now it's moving.
Right,
okay.
right, okay.
Sir, you continue, sir. Same motor, you continue, sir.
Sorry for the interruption. Okay, now it is okay.
Now, okay, sir. Okay.
Okay. So, as per the survey conducted by this World Bank Group and TERI, so there is a potential of 200 gigawatt solar floating solar plants to be commissioned on the reservoirs of in our country. So basically, there is only one basic difference. The entire whatever the technology is same. The only difference is in floating solar plant, all these PV panels are mounted on the water surface area. We will this with the floats, with the help of floats, we will install these floating solar plants. So the what are the where we can put this water bodies is reservoirs, hydroelectrical dams, industrial ponds, water treatment ponds and mining ponds, lakes and lagoons like that. So when we see the general layout and the components of the this floating solar plant, we are say similar to the ground motor solar plants, all the components except float boards. So if we see a typical configuration of a PV power plant for anything, whether it is a ground mounted or floating solar, you can see the sunlight, this whatever the irradiation we call it to come under from the air, the energy. What are these are all these first of all these are photovoltaic system based power plants what we are using. So these are the modules, solar modules. So from the photons of the sunlight, the whatever the energy, it is converted into DC electricity. From DC, not converted, generated DC electricity will be transferred to the inverters, where in the inverters this DC electricity is converted to AC. Then to panels, it will go to our voltage transformers, step up transformers, where we will step up 33 kV or 132 kV or 220 kV as per the capacity of the plants, our capacity of our solar power plants. Up to 15 megawatt, the output voltage or the grid at what voltage we connect is 33 kV. Beyond between 15 megawatt, more than 15 megawatt to up to 50 megawatt, we will go to for the 132 kV transmission. Beyond 50 megawatt, we will transmit step up to 220 kV and we will connect to the grid. These are the, as per the regulations, these voltages are to be maintained as per the capacity of the solar plants. So these are the basic components of any solar plant. So when we go for this floating solar power plant, this is the water body. You can see this water body. This is the ground. So like this, these PV modules are mounted on the floats. This HDPE floats. Actually, practically how we are mounted and all those things, our Mr. Srinivas will explain in this presentation. So these are mounted like this on a race combinedly on all these platforms, whatever the float boards, they are joined together and they will be anchored on the anchoring blocks which are on the bottom of the reservoir water bodies. So from that this anchoring ropes will be connected and all this total as a platform, single platform, it will be connected peripherally to the anchoring blocks. So from these the combined box or junction box, From the junction box, it will go to the inverters. From the inverters, you can see the inverters. As per the capacity of the plant, if the plant capacity is more, the inverters and transformers are mounted on the water surface area itself. So from the center inverters, the power will be transmitted to transformers. From the transformer, again, it will be connected to the grid after stepping up. So this is the basic configuration of a floating solar power plant. So what are the benefits and challenges of floating solar power plant? So one of the major benefit is normally when we put solar plants for on ground, it requires around 4 acres of land for each 1 megawatt. So 4 acres land will be blocked for a period. Normally the life of solar power plants is 25 years. So 4 acres land is blocked for 25 years. In the case of ground mounted solar power plants. Whereas in floating solar, this water surface areas can be gainfully utilized for putting up this floating solar power plants. So another advantage is by putting this FSPV or floating solar plant, whatever the evaporation losses from the reservoirs or ponds, it will be minimized. So that is the one more advantage. And other advantage is normally we require the more irradiation, but not the temperature of this PV modules. So PV module temperatures is raised means the generation will be come down. So when we put this PV modules on the water surface area, so due to the cooling effect, so generation will be more when compared with the ground mounted solar. So other than this, normally when we see the big reservoirs, very big reservoirs, normally there the power generation will be there and the grid connections will be there. So there will be this power transmission lines need not be put for longer distances. So these are the few advantages of floating solar. But at the same time, we have certain challenges also. One of the challenging means on floating solar is first of all the cost of installation. Normally, the floating solar power plant, when compared with this ground mounted solar power plant, it costs around 70 to 80 lakhs more for each megawatt. For the 1 megawatt plant, the floating solar power plant costs around 70 to 80 lakhs more. Because of that, float boards cost and all other anchoring and mooring designs. So big anchoring blocks we have to do and all the anchoring arrangements we have to do. So other than that, this maintenance cost will be more because all the cables, power cables and all those things we lay on the water surface area, although on this float boards, but there are, when compared with ground mounted solar, the life of the component will be less. And there is also a chance of corrosion on this floating solar module frames. That's why actually first time in India we have gone to glass technology where there is no peripheral frame. So Srinivas explained during his presentation, that is one of the main reason for going for this glass technology. So other than that, this anchoring design. So this design is also of unique. Actually, we have done it IIT vetting also for this anchoring designs. The anchoring design is the one of the important parameter and important criteria for the floating solar power plants. So And so these are the few challenges in this floating solar power plant. As I already told, with the land, of course, there is no blocking of land. So we can gainfully utilize the water surface area. It reduces the water evaporation and higher gains in energy production due to lower temperature and less soiling losses and ease of implementation, because here these float beds we can join together and put in the water surface area. There no need to, in the ground mount solar, we have to design the piles and piling, the mounting structure, all those things we have to do. The much civil works will be there. So all those things can be avoided here. So it is for the erection, it would be easy to do this erection of floating solar when compared with ground mounted solar. The only thing is this anchoring blocks, casting of anchoring blocks and shifting of the anchoring blocks is one of the time delaying item in floating solar plants. Other than that, it would be easy. So as I already told, it would be the higher cost, and it is in the nascent stage. Actually, floating solar plants, it is in the beginning stage only. So what is the only around 5 or 6 years back only this floating solar plants started, and we don't know what are the future problems, what are the expected problems and all those things. So a lot of R&D is going on this, and even government of India is looking to give incentives because it is costing around 70 to 80 lakhs more. So now government of India is thinking, it is already proposed and is under the circulation to give a special incentive for the floating solar power plants around 50 to 60 lakhs per megawatt. It is proposed by the Ministry of MNRE. So now the proposal gone to Ministry of Finance. It is to be observed, and they are expecting by November 2023 some announcement may come from the government of India. So these are the in pictorial way. Again, the same things you can see. These are the typical power plant. So reduction in the evaporation, ease of deployment, the assembly is easy, and as you know, we have to do regular cleaning of the solar panels for getting the maximum generation from the solar plants. So regularly we will do almost monthly 2 or 3 times, 2 3 cycles. We will do the washing of all the panels to get rid of the accumulated dust or other any foreign material. So in this floating solar, it would be easy for washing and all those things. And as I already told, increased energy yield from cooling effect of water due to cooling effect. And similarly, when we see this moving and anchoring is one of the problem, and one of the other thing is for maintenance and all those things, safety is involved, because we have to go into the reservoirs and do the maintenance. There is some safety risk is there. So similarly, because this electrical safety, I have already told, this life of the equipment and life of this electrical cables is less when compared with ground mounted solar. In the floating solar, they are susceptible for they are prone for the failures. Similarly, one of the important thing is this bird soiling. So because the birds movement is more in the ponds or reservoirs, that soiling will be more one of the main important problem in floating solar plants. So when we go for floating solar, some of the important design requirement is whatever the floating pontoons means that float boats, what we normally use this SDP material, should be resistant to salt water, alkalis acids, and completely recyclable. And one thing is actually, we have commissioned our floating solar plant in a raw water reservoir of thermal power plant. Almost that is a stationary reservoir because the water, there will not be much variation in the water levels. Whereas that is the most suitable place for installing any floating solar. So, but when we go for this irrigation reservoirs or any other reservoirs, the main problems are there is much variance in the water levels, the full flood level, and otherwise drawdown level. So when the floods are there, the water level goes up, and when the summer season, when the water is to be given to the irrigation purpose, there is likely to that water level goes down, and there is a much variations in the water levels. So when the variations in the water levels are there, it is to be compensated in the anchoring arrangements. So that design is to be taken care of all those things, all those factors. And one more thing, when this irrigation reservoirs and this hydro reservoirs, whenever these gates are opened, there is likely to be the underwater currents or turbulence in the water. So, and similarly, the bottom surface areas, rocky areas, and all those things. So, this anchoring is to be designed in such a way that it will take care of all those things. One more thing, when this water level variations are there, suppose let us take around 10 meters height difference is there between the full flood level and bottom drawdown level. This there is every chance when the water is at full level, it will be okay. The anchoring arrangement will be the 90 degrees and it will be stationary there. But when the water comes down to drawdown level or MDL stage, there is every likely to sway the total floating solar by the 10 meters or 15 meters to one side. And there is likely to the internal heating between the this various arrays between arrays are the, so all those things are to be taken care while designing the floating solar plants, particularly in the this irrigation reservoirs or the ponds and all those things. So suitability of water reservoir is it is best as I told hydropower reservoirs, because hydropower reservoirs, hydropower not hydropower, our thermal power plant reservoirs will maintain a constant level of water, so there will not be much variation. And one more thing is we have to take consideration is the wind speeds. So last 25 years wind speed data we have to collect and we have to design the solar plants accordingly such that that mounting mechanism will take care of the worst wind, that means highest wind speed. We have to take care and we have to design accordingly. So what I have already told, these are the some of the factors for the suitability of FSPV. So while selecting the water surface area for the floating solar PV plant, we have to first see the solar resource. Okay, the water resource, solar resource means I will show one atlas, a world atlas. So if India also we see the western parts of Rajasthan, Gujarat parts will have the more solar irradiation when compared with our areas. Even in Telangana or in AP or whatever the states, within the state also there is a difference of resource. So this solar, whatever the irradiation levels are there, so that atlas is there. in that we can get the data. So where the maximum potential is there, that site we have to select. And we have to see the available water surface area and shape of that water body and the bathymetry. Bathymetry means we will do the bathymetry for knowing the what is the ground conditions of the reservoir, bottom ground condition, because we have to do the anchoring systems and all those things. So we want to know the what is the soil characteristics there. So for that we will do all this bathymetry survey. So whether any rocks or projections are there and all those things will be taken care. We have to design the as per the bathymetry survey. So next thing is this wave amplitudes. So whatever the waves, we will see that normally in the reservoirs, when the big reservoirs are there, certain waves will be there. So that amplitudes also we have to take into consideration. And as I have told, wind speeds, all those things we have to take into consideration. Similarly, subsurface soil conditions. And one more thing is this is shading. Of course, this shading is important for whatever ground mounted or even floating solar for anything. This normally we will do the shadow analysis. So that shadow analysis, as per the shadow analysis, so if some shadow comes toward 365 days data, we will analyze. And whenever this shadow, how much time it will be there, and all those things we will take into consideration. And while designing this solar plants, one of the key parameters is this shadow analysis. So of course, grid access and substation location, because this is to be connected to the nearby grid. How long it is there, how much length we have to erect this layer, this power lines and all those things. We have to take into consideration. So already all these things I have told, safety of personnel, anchoring and mooring problems and all those, these are the challenges and a relatively high cost. All those things I have already covered. So this you can see just for information sake, I am showing a global solar atlas. So we can see this deep red color means there we are getting the maximum solar irradiance. In India also you can see here in Rajasthan and all those things, because I am not showing exactly India map also there, exclusive India maps also there. There we can see completely the detailed this irradiation levels. When we see these western parts, this Gujarat and particularly Rajasthan and all those things, that Bikaner and all those areas, we will get the maximum irradiation. So for same capacity of the solar power plants, there we will get more output from the solar plants. So already I have told this water level variations, wave heights, this bathymetry reports and underwater currents and all those things will play a crucial role while selecting a water body for mounting floating solar power plants. So some of the, because it is wind resistance, we have to take care of the wind speeds. So there are some concepts recently developed. This you can see here, all the panels are mounted. Normally it is like that only, it is like this only. All the panels are mounted inclined towards south. Wherever we see in the here in India, all the panels are inclined towards south, facing south. So like this we will put the panels. But one of the recent design they have developed, that is a dual pitch configuration, such that it will nullify that whatever the wind speeds, it will minimize that wind effects, because all the panels are not mounted in a single direction. So it is one of the solutions they are telling. Now one more thing is because here the edge, all the periphery of the edge of this pontoons or float boats, this submerged weights will be added for stability of this solar plant. These are the now new concepts are coming. So here this anchoring arrangements. So how we have done in our plant, Mr. Srinivas will explain, but this is the basic thing for any solar plant. Here the anchoring blocks will be there. These blocks either cast inside or if big reservoirs are there, they will be cast outside the reservoir and they will be shifted to pontoons and put onto the bottom of the reservoir. From there, this moving flexible rope will be there. On the flexible end of the rope, there is a pedal bar. So these pedal bars are connected to this periphery side of the plant. So to the float boards. Float boards are actually anchored on the float boards. So these panels will be mounted. So normally all the this solar modules are assembled on one edge of the water reservoir, then they will be towed to the actual point and there they will be anchored. So same thing. So here already how when the water surface area is suppose let us see that the water surface is in the here when the flood level or the maximum level is there, then this floating whatever the rope, this anchoring rope will be in the vertical portion, 90 degrees condition. So when the rope is when the water level comes down, this rope will come like this with certain angle. So this when the total array it is there, when the water level comes down, it will move like this on the water surface area. So whenever this angle goes on increasing, there is increasing in the tension of the on the higher tension will be there on the this anchoring rope. So all these things will be designed. It is very critical parameter in the floating solar is design of anchoring systems. That's why we have done it. We have got it done, vetting done by the IIT Madras, where this oceanography department of oceanography is there. Actually we have contacted many IITs, IIT Hyderabad, IIT Delhi, and all those things. They could not able to do that design analysis and all those things. Finally, we could able to get it through IIT Chennai. So that is a completely engineering design and all the by taking all the parameters, it is to be finalized. So these are the various types of tying arrangements. So actually, what are the failure modes in the floating solar? Some I have already told, corrosion will be more, so we have to take care the moisture hardened materials or corrosion resistant materials in this while selecting the material for the floating solars. Similarly, this back sheets and all those things, normally we will see the back sheets on the PV modules. So here we have used the glass in our 5 megawatt floating solar plants. So these are the various floating solar plants and their anchoring arrangements and cables laying arrangements. So normally once it is assembled at the bank of reservoir, they will be towed to the actual anchoring point like this, and there the anchoring will be done. So these are the cable laying arrangements. So normally in the big reservoirs, the concrete blocks for anchoring blocks will be prepared on the bank of the reservoir, and they will be shifted, and the barge is used to lower to that concrete bank blocks into the reservoir. and the drivers will go there and because that is in the deep water, 15 or 20 meters below the water surface area, the persons have to go and do this anchoring arrangements and all those things. This because here when compared with land-based PV plants, floating solar plants, one of the things already we are discussing, there are likely of corrosion and all. Similarly, this electrical cables of there are chances of electrical cables failures and electrical components also due to moisture and all those things. So all those things we have to take into consideration while doing the maintenance, high humidity environment, and similarly this risk of persons because that deep water reservoirs they have to wear the safety jackets invariably, and they have to take care of all the safety precautions. So these are the some of the bird drainages. So these are when we see this to do the thermal imaging. This we can see this wherever the normally with this now the technologies are there with the drones. This infrared thermal infrared survey imaging will be taken, and wherever the like these hotspots are observed, immediately cleaning or rectification activities will be taken up. So some of the maintenance issues, if any conduits or cables or anything failures because of this water, there is a likely failures or tripping of the systems and biofueling like this. And similarly, in some of the reservoirs, floating solar plants, some of the animals or some of the other insects, there is likely to go on the solar plants. So these are the some of the solar plants, floating solar plants in various countries. So now there are new concepts in this novel concepts means latest developments such that normally even ground mounted solar also there. This tracking systems are there because the sun moves from east to west. The plant panels also the inclination also changes like that. Here the total plant itself will rotate as per the sun direction because the sun direction when the sun rays the incidence is when the 90 degrees, then the generation will be more. So for that, the total panels and the plant will be rotated as per the sun direction. So this is the one of the R&D project taken up in other countries. Here also tracking systems. So this is one more concept. We are all just R&D projects only. Lens concentrator means to get the more concentration or more solar energy concentration irradiance, what we call. So such that the generations will be moved. So these also. So now the submerged floating, even submerged floating thin film systems, we are seeing here very small plants. So these are the basic system, very brief details and what are the parameters will be taken while considering the floating solar plant. So I have tried to narrate the basic concept. Now our Srinivas will tell what actually we have done the practical way and what are the challenges we have faced and what is the success story and how it is now our plants are performing and all those things. Mr. Srinivas will tell the total details. Thank you for all the participants and listeners for patient listening and all these things. And I thank Institute of Engineers and organizers for giving me this opportunity. Thank you.
Thank you, Surnaranaj Garu. You have very well explained the complete solar system, how the solar panels are used for generating the solar energy and all those things. Ground mounted, various different models from basic to floating solar, and what are the novel concepts coming up in the floating solar projects. All those things you have covered very well. So there are so many question and answers, around 26 persons they have raised the question and answers. So at the end of the session, after completion of the second presentation by Mr. Srinivas, we'll take up the all the question answers, and at the end of the session we'll answer, the panelists will answer, and I will also moderate the next coming session. Now I request Sri Srinivas Garu, please proceed with your presentation.
Sir, thank you, sir. Good evening, sirs, for all. Now, where glass to glass floating solar PV power plant in SCCL, where sun meets water, the first dear glass PV module floating solar plant in India. There now on screen, we are the picture is showing the present or 5 megawatt floating solar at STP. That behind that is a 2 into 600 megawatt single thermal power plant. So that is a complete view of the one side, from north side view of the present working 5 megawatt solar plant. After this, we are going to now works are going. We are going to install one more thing, 10 megawatt floating solar plant besides of this plant. So that is the second reservoir, first reservoir. So let us go to in detail.
This floating solar plant is ours only. You can see with the backdrop of thermal power plant, this floating solar plant, a beautiful picture here. This is our actual 5 megawatt solar plant working at in our solar STPP, that is thermal power plants.
Yeah, please continue, Srinivas Garu.
Now we will see now. Basically, I am not going to detail here. Just our sir, GM sir told everything. Just I am mentioning the salient features of this present 5 megawatt plant. So area of the reservoir.
Srinivas Garu,
Sir.
please cover what are the challenges you have faced in installing
Okay, sir. Okay, sir. One by one. I will.
This glass to glass technology, and what are the advantages of glass to glass
Right,
technology?
yeah,
Our main presentation is on glass to glass technology.
Definitely. Just
first time used in our Singareni colleges.
Okay, definitely. I will give just brief salient features of the plant. So reservoir is R1 is 22 acres. Basically, is the reservoir depth of the reservoir is 7.5 meters. Fortunately, this is man-made reservoir. Fortunately, we got man-made reservoir. Basically, it is, sir.
Srinivas, slides
అవుతున్నాయి సార్. Okay.
Slides are not.
First slide కనిపిస్తుంది మాకు.
Oh, okay. Just 1 minute, sir. I will change, sir. Okay.
Yeah, now it is moving.
It is okay.
So now it's okay, sir.
Okay. Yes.
Next, I will check once. Okay. Next change.
That is okay.
Alright, okay. Alright,
Okay.
Okay. Okay, sir. Basically, two reservoirs are there. One is R1, one is R2. We erected 5 megawatt solar plant in R1 reservoir. Is about 20 acres, covering it 20 acres. Water depth, full reservoir level is 7.5 meter. So our DC capacity is 130%. AC to DC 1:1.3 and 130% DC. So area of the plant 17.5 acres, almost 3.5 acres per megawatt. So total project cost is 26 crores. So almost cost is 5.24 crores per megawatt. So we used PV module type multi-crystalline beer glass, frameless. So I will explain later what is the advantage of frameless. So module wattage is 335 watt. So module make nose green Hyderabad based company. Next module tilt angle 5 degrees. So type of floating system. So where we use floating system is multiple HDPE floats interlinked to form modular platforms and connected to the reservoir bed through anchoring and mooring system through bottom anchoring system. So next later I will explain anchoring technology. Dead weight anchoring. Dead weight anchoring through concrete blocks of different weights up to maximum weight. One block is 24 tons. So many total 90 blocks. We cast 90 blocks. In that block, maximum weight is 24 tons. Next, next total board weight of the solar farm. Total board approximately 1,000 tons. Total, including panels and float boards, everything. Total weight is 1,000 tons. So number of inverters. Inverters are offshore. So base 6 numbers inverters. 5 into 840 kilowatt plus 1 into 800 kilowatt. Total 6. Total is 5 megawatt. So our substation is, our line is evacuated to.
Srinivas.
చెప్పండి సార్.
ఈ డీటెయిల్స్ కంటే ఎక్కువగా మనము ఫీల్డ్ లో మనం చేసిన ఇది వాటి మీద కొద్దిగా ఎక్కువ కాన్సంట్రేట్
రైట్. ఓకే. సో
టైం ఇస్
ఓకే నెక్స్ట్ ఐ విల్ స్పీక్
only 20 minutes is left for you.
ఓకే. నెక్స్ట్ రిజర్వాయర్ డీటెయిల్స్. యు గో ఫర్ నెక్స్ట్ reservoir details. Next one. So regarding, we are proud to announce that we are first in India to commission a dual glass PV module floating solar plant at Singapore. Next one. So basically glass to glass PV module.
Slide move అవుతుందా?
ఓకే సార్, మూవ్ అవుతుంది.
ఇక్కడ సెకండ్ స్లైడ్ లోనే ఉంది ఇక్కడ.
ఇప్పుడు నౌ చూడండి, గ్లాస్ టు గ్లాస్.
ఇప్పుడు ఓకే.
Glass to PV module. Basically, there are two main structural designs PV module: glass and back sheet. One thing. Second one is glass to glass module. So where now we will concentrate on glass to glass module only. So double glass is a technology that uses a 2-layer tempered glass to protect the PV cells inside instead of the traditional polymer back sheet and back of the modules and with aluminum frame. So POE, polyolefin elastomer, is used to bond the front and back glass, and this module lasts long and also ultra resistant to any weather conditions. So basically POE is brought from China. We brought to China from our vendor, EPC vendor brought to POE from China. Nothing but the bonding agent. So basically our maximum power 335 watt. Next I will skip this glass module. So next one, weight. Now, salient feature of the plant. This floating solar plant is moored in the reservoir by means of gravity anchors at the reservoir bed, which will keep the plant in desired position. This floating solar PV power plant is designed such that it can withstand wind speed of 130 kmph. So due to its speed, last 25 years data we collected from IMD Pune. At 1 year, at previous 1 year, 2019. So the speed of the wind speed is recorded 33 meters per second. On that basis, only for 2 seconds only. On that basis, our SCCL insisted our VPC vendor to design for that speed only. Even though 2 seconds are occurred previously, 130 kmph. So this project faced several challenges, such as particular design and manufacturing of float boards by the Indian company Float Volt for meeting all testing standards. So, and fixing frameless glass to glass module onto the float boards. It is challenging. The overall design of the project is vetted by Indian Institute of IIT Chennai. The first floating solar project to be vetted by a premier institute like IIT. Next, double glass solar panels offer a range of benefits. Now we will go for benefits of this double glass. Basically, the double glass panel without a protective sheet at the back dissipates heat well. So during generation, normally panel module plot will be heated up. So that the dissipation is very important. Otherwise, efficiency will reduce. So now it is back side also glass is there. So its efficiency decreases more slowly over the period of operation. Traditional panels by about 30%. So back sheet too. So now it is a glass one. So automatically it generate more generously will give that plant because glass to glass module. One thing, one benefit. Second is the tempered glass layers provide superior protection against environmental factors such as wind, rain, and hail, as well as UV radiation. This can help to increase the lifespan of the solar panel and reduce the risk of damage or degradation over time. So that is the reason double glass modules typically come with a 30-year warranty. So firm is giving 30-year warranty due to his silent design. And the panels themselves generate 25% more energy because heat dissipation is more. Next, frameless PID, potential induced degradation is 0 because no earthing, because there is no aluminum frame around the panel. There is no earthing, so no electrons. No PID is 0 here. That is very more important. Resistance to chemical reactions is another benefit. Glass doesn't react with many chemicals and environmental elements. This property ensures no chemical reactions will occur between the sheet of the glass and the solar cells or epoxy resin that hold the panels together. So no ingress of moisture because of our we are using POE bonding. Next one. Another advantage of glass to glass PU modules is their improved performance because of the use of glass allows for better transmission of light because both sides of glass, upper lower, because it is a low iron content, which can increase the efficiency of the solar panel. Dual glass panel is frameless, hence no need for ground connection and no need for earthing system. So and moreover, the zero PID and potential induced degradation, zero PID. That is the main important. The completely smooth glass surface provides only one coefficient of expansion, and uniformly it will expand through the use of only one material. The glass surface is easy to clean. It is easy to wash off dirt from it. Microorganisms don't multiply on it. For example, moss doesn't grow. And normally module will have with the panel will aluminum frame. At the edge of the aluminum frame, salt and salt to precipitate. So in a long run, transparency will come down. So here there is no problem. So because of total glass, no frame. Finally, glass PU modules are also more aesthetically pleasing than traditional solar panels. The use of glass creates a sleek and a modern appearance. Even though many advantages are there, some drawbacks are there, such as higher cost, because it is a natural higher cost compared to normal panel. Weight problem. So some weight is more than compared to normal module. And complex installation also, because we have to take very care handling of the panel and at site transporting to location also. Different problems we faced. But all these are outweighed by the benefits these PU modules have in the long run. Next, HDPE floats. Normally, I will just briefly I will explain. HDPE, high density polyethylene. These floats are specially designed for to fix the panel ports and water. So different floats are there. Equipment float for carrying the SMBs and walkway, big walkway, small walkway, and next to panel float, different. But anyway, whatever may be floats, so all are made by HDPE material, high density polyethylene. So these are basically UV resistant. So carbon black granules will be added to this while doing manufacturing. So UV resistance, they will become UV resistant. Here we are used total different floats, almost 50 around 1 lakh. Almost all floats together and 1 lakh different big walkway float, small walkway float, equipment float, panel float, support float, different floats are there for different purpose. Total for 5 megawatt to even though module, our modules are 20,000. Even the 20,000 modules are there. Floats are 1 lakh, almost 70 to 80,000 floats are used for different purpose. Minimum standards required for floats. So floats should be able to withstand strong winds. Floats should be UV resistant and should not irradiate over time. Because UV resistant, because in the long run it may be brittle due to observation of UV rays. So we have to add carbon black granules to reduce to make UV resistant. The floats should sustain waves and refrain itself from bends and breaks. Should not bend or breaks due to amplitude of waves. So fortunately, we don't have any waves because it is a man-made reservoir. Next, anchoring and mooring design in SCCL, where we did at a 5 watt floating solar plant. Briefly, I will explain. Anchoring and mooring design of glass PSPV plant in SCCL has been designed considering the following factors. Minimum water depth is 5 meters. We consider for design purpose. Maximum water depth of 8 meters, because our FRL is from bottom level to only 8 meters only. So we take into consideration 8 meters top level. Design wind speed of 35 meters per second as per the historical wind data of past 25 years as received from IMD Ramagundam weather station. Luckily, we underneath of the water, so our bed is very smooth surface, just like this is a man-made reservoir for thermal power plant. So basically, our bottom bed is 75 mm thickness PCC bed is there, bottom surface of reservoir. So actually, it is now present it is saturated. So that is the main. So should not while erecting, while execution of the plant should not damage. We have to take much care. So that is one of the challenge. Based on the above factors, bottom anchoring technology, dead weight anchors has been adopted in glass to glass FSVP plant SCCL. So we adopted dead weight anchors. So this is the where we used this type of the anchoring mooring system. The sea. So anchor block is seen on a square block. So almost this is the 90 blocks. North side is a different way to, south side different way to, depending on weather condition. Now the but anchor block a polyester rope with 20 mm dia, a waterproof polyester rope, anti-rust. So then after a chain is there, galvanized chain, GI chain, 1.5 meter. Then after some plate, delta plate, some is a triangle plate is there to take loads. So different position. So next turnbuckle. Then after sweater bar. The sweater bar is connected to our floating board. Different position. Total is 90. Such design is total 90 numbers. So attached to our total board, 1000 tons model board. So sweater bar is connected to. This is our anchoring mooring design. So where we did the anchor casting anchoring system is, fortunately our reservoir is divided into two parts, R1 R2. So and so we evacuated total water in R1 reservoir. Then we did casting of anchors direct to manually without water only. But this is a challenging project because no vehicle will go into the reservoir, because the 75 mm PCC bed will damage. So manually, many manpower, by engaging manpower, handling of concreting. So totally we did total 90 blocks. Then after anchoring of the 90 block, casting of the 90 blocks, totally our floating model board also designed on surface only without water. The special type of project without water only, total model board, including modules, everything we fitted on only surface of the bed without water. Slowly we after that checking of total testing of modules, everything. Very slowly we filled water by observing everything factors, design, I mean tensions and anchoring tensions particularly. So we face some challenges I will give here. Key challenges of the glass PSV project in SCCL. The primary challenge is that floating solar projects must be sustainable for 20 years, basically. The key challenges are of the project are categorized as follow. We encountered some challenges below. We mentioned design challenges, market challenges, execution challenges, operation and maintenance challenges. So briefly I will explain design challenges. There are no companies manufacturing glass to glass modules with DCR, domestic content norms. So a complete new product has to be designed to suit a SCCL floating solar project, because our need is as per need to where to go. So that's why present in India, no companies manufacturing glass to glass module in India as per DCR norms. That's one is challenge. Manufacturing GG module with different POEs to meet the desired melting point. Finally, with imported POE from China, best GG modules have been manufactured. Obtaining IE certification for GG modules. So IE certification is very important. So we have to quality. Regarding quality, we have to maintain ultimate. So IE certification is important. So we tested these modules at Germany, one of the lab of Germany. So during COVID period, we suffered a lot of, because of COVID period, all labs are closed in Germany. The Germany country suffered during COVID period. So even though we succeeded by many challenges, by taking challenges, high certification from GG models with the DCR norms, I taken almost 1 year. It took 1 year, because of it is exporting to, sending to Germany and testing it, and taking reports from there itself. Is taking almost 1 year due to COVID. Designing of floors to withstand all possible hazards for holding frameless glass-to-glass module. Designing of anchoring and mooring system without damaging the reservoir, because our primary objective is reservoir, is linked with our thermal plant. So we have to take care about our thermal plant also, as well. So bed of the reservoir should not damage. In that aspect, we have to design anchoring mooring as one of the challenge. Vetting the design of model floatboard platform from IIT. So Premier Institute IIT Chennai, Department of Oceanography, vetted by this design. Designing of cable routing and its management by providing extra length in the form of slack. So cable routing by water level decreasing, increasing, automatically cable way should do expanding. So that is one of the design. Moreover, our inverters, our transformers, very totally outside the water. So our DC will come out from the water. So total inverters and transformers are outside the water. Only these SMBs and modules are inside the water. So all the above designs are unique and specially made for SCCL floating solar plant. The unique project. That's why it is a unique project. Next, market challenges. Availability of high efficiency DCR solar cells, as vendors failed to adhere delivery commitments due to price hike in solar raw materials and products, due to COVID, due to government policies. So high efficiency cells are at the time not available. Availability of raw materials, example POE for sandwiching glass-to-glass module in the market pertaining to glass-to-glass. Finally, our vendor brought from China. Increase in price of raw materials also after COVID, affecting the cash flow of EPC contractor. Availability of HDPE raw materials and its rate fluctuation for manufacturing floats. Imposition of BCD, basic custom duty, as the government policy on solar cells and other components by the government, which increases the module cost. Material availability pertaining to mooring system. These are market challenges. We face a lot of each and everything. One by one, we overcome everything. Execution challenges. This is one of the toughest challenges, because our reservoir is totally, there is no way into reservoir. Only just smart steps are there. No vehicle will go into, totally manually. We have to handle every module. Every module we have to take by 2 persons, because it's a weight. 2 persons from almost to half kilometer from outside the storage site to say half kilometer is to take by 2 persons with by walk only through steps to into reservoir. That is a major challenge. Emptying of reservoir for avoiding the damage of PCC bed of reservoir during the installation of anchor blocks. Fortunately, this is the best one. We got best opportunity to total dewater the reservoir, because other reservoir is there to cater our solar thermal plant operation. In situ casting of anchor blocks, as there is no scope for movement of machinery into reservoir. So we already the Ajax machines, everything is we have to kept on bund. From bund we have to install every chute to send the concrete to anchor blocks. This type of challenges are we encountered for casting of anchor blocks, transportation and handling of glass-to-glass modules at site, and carrying up to installation location, availability of desired dimension trucks for transporting them to site, shifting the materials manually into reservoir with huge manpower, mooring the platform with different combinations, refilling the reservoir gradually, and observance of bending of edge platform due to weight of mooring system and insufficient buoyant force. Actually, pad totally was erected. After that, we are doing filling. So during filling, side of the figure, one so circle is there. Observe it. So splitter bar with frame was bent due to buoyancy, insufficient buoyancy force from bottom, due to weight of the anchor, due to weight of the mooring rope and chain, everything, total weight. So we stopped refilling of water, and we considered we did one experiment. We put underneath of this frame 3 to 4 floaters, small floaters, but not successful. Again, we put bigger equipment floats, one by one, two rows. So similarly, we totally we adjusted one by one, just water filled. Then after that, floater frame will uplifted. You see in next photo. Condition of float frames after activation of action. This is the practical thing we observed while filling the water in the reservoir. This is the so we afraid something. So what so design aspect. Anyway, we successfully completed this task. Execution challenges. This is a major execution challenge. Placement of additional floats beneath the float frames for creating buoyancy force in the opposite direction, thereby lifting the float frame upwards to avoid bending of edge flattening. Next is operation and maintenance challenges. Since FSP plants are installed on the water surface, basically it is safety. O&M issues in the safety of the manpower. Next bird droppings, replacement of electrical parts, maintenance of cables and wires is a complex things to handle. Next to constant movements of floats. So due to wind, due to cyclones, far away from this place, even though, so due to wind pressure, float board will move some little bit. Anyway, anchor mooring system is there to bind that board. Next, normally this is well known to everybody. So PR, plant performance is the PR and the CAFU. So this is the we got 85% PR against guaranteed 80%. This plant we got 85% PR against guaranteed 80%. Next CAF also we got 24% against 22.8% due to one of the best we observed, one of the best plant in the quality wise, and we erected, we satisfied with this erection of this plant. Now we are going to erect one more 10 megawatt plant FSPV in second reservoir. Thank you for everybody. So mute.
Thank you, Mr. Srinivas, for presenting a fine this one on challenges. What are the challenges you have encountered, and what are the design aspects you have taken care of while executing the 5 megawatt floating glass to glass floating solar project? So this is first of its kind in India. So definitely when it is a first, there will be so many challenges, so many difficulties, so many design parameters will come into which we will not expect during design aspect, but while executing, definitely we will be getting so many challenges and successfully have overcome all those challenges and commissioned the project. So now question and answer session. Our participant, they have asked some questions. So the first question is Mr. Reno Rapai. Mr. Srinivas, please answer this one. How to clean these panels? Easy through by small boats. How the panels are being cleaned in the floating solar project?
So boats are not required. So we'll put one motor inside the water. So because our water is basically a river flow water, Godavari and Pranagita river water. So normally ppm of water is turbidity is very small thing. Even turbidity is more, we have to erect one RO plant outside the reservoir. So by motor, we have to take that water into on floatboard by laying HDPE pipes, small HDPE pipes, whatever may be. So by using this water, we will clean by manually. Boats are not required. Boats are not required. Manually, we have to do.
No, how we, I think the question is how to clean this, how to enter into the panel area and how to clean it.
One thing,
Yeah.
So because there are completely panels, in between panels, walkways are there. The manpower the maintenance persons can move in the through the walkways to the all the entire plant. It is like a grid, and in between completely this walking platforms are provided horizontally and vertically also, such that the persons can move easily
from the bank to the
from the bank. There is a walkway, actually walkway platform, and once entered into solar plant, this area also, these walkways are provided. So all the persons, maintenance persons can move on the walking walkways and do the maintenance activities. Not only the washing, all the other maintenance activities also conveniently they can do.
Yeah, thank you, Rajgaru. And one more suggestion from Mr. Anil Kumar. So birds can be kept away by sonic gun as was done near the airport runways. Yeah,
It is a good idea. This can be actually
implemented.
thought of.
And one more question from Bhagavati Perumal Pillai. Are the subsea cables a special design? Srinivas.
Mute. Srinivas, mute long.
Okay, sir. Cables, water resistant cables, sir, that category is enough. Not subsidiary cables, water resistant cables, some IS code is there. So we have to follow IS code, water resistant cables, that is enough.
Yeah, one more question, Mr. Rajgar, please answer this one. What is the per watt cost difference between normal PV panels and glass to glass?
There is actually there is not that much difference of this the difference between normal panels and glass to glass panels. Nowadays, actually, in ground mounted solar plants, now we are going for this bifacial modules. That means from bottom also certain energy will be it can be generated from the ground also. After the actually the whatever the sun rays, sun irradiation is there, it will be passed through the panel to the ground. Again from the ground certain reflection will be there. So for that nowadays this bifacial module concept is developed. So for that definitely this glass to glass module is only the solution. So from bottom also certain from the whatever the radiation reflected from the ground, it is absorbed on the bottom side of the bifacial modules through this bottom glass, and generation will be around 10 to 15% more when compared with the this single phase modules. So now the glass to glass modules slowly coming up. So next future market will be that actually to get the more generation, this bifacial concept is coming up now.
One more question, Mr. Srinivas, please, can you please answer this one? Is there any security system installed that the cameras and all those things?
Right, okay, we installed cameras. Normally, zoom type CCTV cameras. We installed by monitoring the even night vision cameras also. Without lighting also, we can see total floatboard, total model floatboard. No problem. We have to install.
One more question, Mr. Srinivas. How do you monitor the performance of PV system?
Normally, one is the universally one index is there, performance ratio. The universal index and accepted by all over the world. The PR is the one of the best index.
Yeah. For that one, I will add to your this one. The performance ratio of this particular project of 5 megawatt floating solar is 89.38, which is the now highest to the best of my knowledge. And it has already generated 3.4 million units as on date after commissioning in January. So this is the highest performance ratio what we have achieved till now. One more question is there any robotic support to clean the panels? Yeah, here we are not using any robotic support for cleaning, manual cleaning only is being done, but that can be done.
Actually, this concept is already there in big ground-mounted solar plants. This concept is introduced with this robotic type of cleaning up modules. So it is there already in some of the plants, but not at our end.
One more question to Mr. Srinivas. Is this a toughened glass used? That glass to glass what we are using, is it a toughened glass?
Yes,
Or
yes.
any special glass?
Yes, it is toughened glass. Width is 2.5 mm. Low iron glass we used toughened glass. 2.5 mm width.
Yeah. One more question to Mr. Rajgaru. If any breakdown happened, entire system will be affected or not?
No, that is the actually as per the type of breakdown, because if any in the suppose certain panel so module some breakdown is there, the performance that much it is limited to that area only. If it is some inverter failure is there, so that group of modules whatever they are connected to that inverter, that much generation will be, the generation loss will be there. If we take the transformer, suppose main transformer, if the main transformer something problem or shutdown is there, definitely the total entire plant will be shut down for that time. So it depends upon the breakdown happened in that component. As per the component, this again depends upon that.
Mr. Srinivas, one more question for you. How do you handle algae formation and floating during monsoon season? That నాచు ఇవన్నీ వస్తాయి కదా అవి ఎట్లా హ్యాండిల్ చేస్తాం?
Normally, one studies there internationally, algae formation is not confirmed. Algae formation by the floating board system. So our GM sir will tell, sir, you explain, sir.
Actually, studies says that with that actually floating solar plants, this algae formation is drastically reduced in the reservoirs. This is one of the studies says. So we have to see practically.
And one more thing
we have not faced, but we have to see what is the in forthcoming seasons. If it is happened, then we have to see. But the study says that it will drastically reduce.
One more thing, our water is continuously drawn up by thermal power plant, and fresh water will be makeup water will be coming.
Okay.
So that may be what we feel that.
For us, but
yeah.
How the other plants will be, that is the question.
Yeah.
So here my colleague actually who is listening this presentation asked one interesting question, means important question. So when the solar energy is coming in big way, still why we should depend on the thermal power? Why we are going to increase the capacity of still thermal power plants in India? So it is one valid question for the power sector. So when we see this renewable power, or even when we let us restrict to solar power is not a RTC power. RTC means round the clock power. It is not a round the clock power. It is limited to certain time. And morning, suppose let us say 6 to 6. Even though in that also, morning 10 to 3, it will be the peak. So there are peaks in this. So for the supply of this power, actually, this energy storage systems are to be developed. So now there are certain concepts of BESS, that is battery energy storage systems, and pumped storage systems. So they are already, in certain plants they are introduced. Here in even our one of the plant, our CNOS is doing to introduce 1 megawatt BSS. So, but the problem is they are proved to be very costly at present. At present, the storage is very costly. The unit cost is going up to around 8 rupees or 9 rupees. So it is costly. Once it is comes in a big way, mass production is there, then the costs may come down, and then you can depend on the solar power for 24 hours. Until unless the storage systems are developed, we cannot rely only on renewable power or solar power because this grid balancing and everything is difficult. So that's why we still going depends up to on this thermal power plants. And as per this Ministry of Power and NITI Aayog, they are expecting that up to 2040, this dependence on the thermal power plants continue, and they likely to add certain capacities also. Nowadays, now we are adding actually thermal capacity. We are increasing because by 2030, our expectation is around 40 to 50% growth in demand. So to meet that, now again we are going to capacitation of thermal power plants. Although we are very much progress, there is very good progress in. We are going in big way on renewable power, that to solar power. But there are certain limitations. Mainly this limitation, although this solar power is very cheaper compared to thermal power, but we have to depend on the thermal power because of this grid stability and 24 hours supply, power supply.
So with this, we'll try to conclude the today's session. So thank you, Mr. Sonarayan Das Garu and Srinivas Garu. You have given valuable information, presentation on this subject. So in spite of your busy schedule, you have agreed to participate in this webinar. Now I will hand over the further proceedings to Mr. Our Honorary Secretary, Kandakumar Garu.
Thank you, sir. Thank you very much, sir. Very, very excellent webinar today is you have done, sir. I thanks to the Honorable Chairman of the Institute of Engineering Kothagudem Local Center, Sri Janaki Rao, give innovative ideas to our. This is our third program, sir. We are giving the novel ideas, and globally it is the first time in the Singaran college, and also the presentation panelists also very experienced personalities. They are giving the great technical inputs. This is really highly informative to our audience, and also as a students as well as the engineers and also the industrial people. Thank you very much, sir, both panelists. And also I thanks to the our approved mechanical division of the Kolkata by immediately giving the approval of this program, and thanks to our technical director of the Kolkata IE Center, and also thanks to our office bearers and also the joint secretary, Dr. Srikanth sir. He was also background in the preparation of these works, preparation of the webinars, some more works, and also thanks to all my corporate members of the institution of the Kothagudem. And also special thanks to the Singaran College Company Limited, giving this very valuable inputs, informative to the sharing to the statewide and countrywide and nationwide. This is a very valuable to for those who are in the research side. They will very valuable input, sir. Thank you, sir. Now I am concluding this one. As per our schedule is concerned, now is the national anthem. We would like to play here. Please stand.
Play చేస్తున్నారా? जनगण मन अधिनायक जय हे भारत भाग्य विधाता, పంజాబ సింధు గుజరాట మరాఠ ద్రావిడ ఉత్కళ వంగ వింజ హిమాచల యమునా గంగా ఉచ్చల జలధి తరంగ తవ శుభ నామే గాహే तब जयाशिष मागे गाहे तब जय गाधा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे. Thank you.
Thank you, sir. Thank you very much.
అదే ఆడియో ప్లే చేసేయాల్సింది.
Yes, sir. Yes, sir.
ఓకే ఓకే ఎనీవే థ్యాంక్ యూ ఆల్ ది పార్టిసిపెంట్స్.
చూసారు CL 10%.